Okay, good morning. Welcome to
MathForKids number 153.
MathForKids number 153. In MathForKids 149, we discovered that the Earth was moving about 67,000 miles an hour around the sun. In MathForKids 150, we discovered that Jupiter was moving about 29,000 miles an hour. MathForKids 152, we did something different. We did a geometry problem about walking around an area, I think. But in MathForKids 152, yesterday we found out Mars was moving about 53,000 miles an hour. Today we're going to figure out Mercury. So would you draw Mercury and the Sun for me? Okay, so what's special about Mercury's orbit?
It's the closest orbit to the Sun.
It's the closest orbit to the Sun. And like the other ones, we're going to pretend it's a circle. The radius, I think, is 32 million miles, is that right?
I think it's about 36.
36, 32, I don't remember actually. 36, you're right. 36, I had it written down. So it's about 36 million miles. And do you know how many days it takes Mercury to go around the Sun?
88.
How did you know that?
I read it.
That's right. See, I don't have to look all this stuff up. So it takes 88 Earth days to go around the Sun. Okay, so that's our...
Days.
What's that?
Not Mercury days.
Yeah, I don't know how many Mercury days it takes to go around the Sun. Just trying to see where we are, okay. All right, so the radius is 36 million miles. And the time is 88 days. Okay, so I guess I'll erase that over here. So, how do we figure out what the speed is? What's our formula for speed?
Speed is distance over time. Well, the distance is the circumference.
Okay, and what is the circumference?
Circumference is 2 pi times the radius.
Okay, so 2 pi times what?
Times 36 million.
36 million. Divided by?
88.
88 days. Okay, so we have 2 pi times 36 million miles divided by 88 days. And what's our approximation we've been using for 2 pi?
It's 6.3.
Yeah. Pi is 3.14. 2 pi is 6.28.
What?
Approximately. So we're just going to make our life easy and say that's about 6.3. Okay, so we have to do 6.3 times 36. Or 36 times 6.3. So, 0.3 times 6 is?
It's 1.8.
1.8. 0.3 times 3 is? 0.3 times 30 is?
Is 9.
9. 6 times 6 is?
36.
36. 6 times 30 is?
Is 180.
180. Okay? Oh, so this is a little complicated. Okay? So, let's do this up here. I get a 0.8. 1 plus 9 plus 6 is?
Is 16.
16. 30 plus 80 is?
Is 110.
100 plus nothing is?
Is 100.
100. So what does this all add up to?
It's 226.8.
Okay. Which we can just approximate as what?
As 226. How about 227?
227, yeah. So the distance is about 227 million miles. And we have to divide this by, I didn't leave myself enough room here, divide it by 88 days. And we're going to find out how many miles Mercury goes per day. Okay? So 88 into 227. What would you guess for that?
How about, let's try 3.
Okay. What's 3 times 80 already?
It's 240. That's already too big.
It's already too big. So
2.
this is 2. It's more than 1, but it's going to be 2. So what's 2 times 88?
2 times 88 is 176.
176. Okay, great. 227 minus 176?
It's 100. It's 100. 20 minus 70 is negative 50. And 7 minus 6 is 1. 2 minus 7. I got 200 minus 100 is 100.
Right.
20 minus 70 is negative 50.
So what's 100 minus 50?
It's 50.
Okay.
And then 7 minus 6 is 1. So it's 51.
51. Okay. So 88 into 510 now. This is a little tricky.
How about 6?
Okay. 6 might be a good guess. What's 6 times 80?
It's 480.
So 6 times 88 is 480 plus 48, right?
Yeah. Which is 528.
Okay. So is that too big?
Get too big.
So that was times 6. So what's it going to be?
5.
It's going to be times 5.
So that's 400 plus 40, 440.
And what's 510 minus 440?
It's 100. 1 minus 40. 10 minus 40 is minus 30. So 100 minus 30 is 70.
70. Okay. Now let's do one more. 88 into 700.
88 into 700. How about 8?
Okay. 8 times 88 is 640 plus 64.
Which is bigger. It's 704.
704.
Just
Too big. But you know what? That's really close. So let's just since we're approximating, let's pretend it goes in exactly that. Okay? So that's super close, right? 704 and 700. So Mercury moves very nearly exactly, according to our calculations, 2,580,000 miles per
day. Now we just gotta.
Now, how do we figure out miles per hour?
We divide
By
24.
24. Okay? So let's do that calculation real quick and we'll see. Now, what do you expect? Do you think Mercury is going to be moving faster or slower?
Faster than Earth.
Faster than Earth? Okay. Let's see. So 2,580,000 miles per day divided by 24.
24 goes into 25 once.
Once? Okay, now, put your thinking cap on. 25 minus
1.
24. 1. 24 goes into 18.
No, doesn't go.
0. 24 into 180.
How about 6?
Figure it out. 6. What's 6 times 24?
It's 120. It's less.
Okay, so what would be that, I guess?
7.
Okay.
So 140 plus 28 is 168.
Does that seem pretty reasonable?
Yeah.
Okay, 107, 168. 180 minus 168 is?
Is 120 minus 8 is 12.
12. 124 into 120 is?
20, it's 5.
5. And it actually goes in exactly, right?
Yeah.
So Mercury moves about 107,500 miles per hour.
It is faster.
It is faster. So Mercury is about, let's call it 108,000. Pretty good, right?
Yep.
So Mercury moves twice as fast as Mars. Not quite twice as fast as Earth. So Mercury's moving pretty fast. So
It's almost like 5 times as, maybe 4 times as fast as Jupiter.
well, not quite, because what's 4 times 29? Actually, what's 4 times 30? Make your life easy. 4 times 30 is
120.
120. So it's not quite 4 times as fast, but it's definitely, Mercury is definitely moving fast. And you know, Kepler, have you ever heard Kepler's name before?
Yeah.
Who was Kepler?
It was this.
What's Kepler famous for?
Well, we just put a Kepler Space Telescope.
Okay, there's a Kepler space telescope named after Kepler. Do you know who Kepler was? He was a famous astronomer.
Yeah.
And he had a couple of laws. And one law he found was that for the planets, r cubed over t squared. So the radius, if you take the radius cubed over the time it takes to go around once
Yeah.
and square it, so this is a constant. So Kepler was doing all the same calculations we were doing, except he was figuring out the radius and the time it took to go around. And he came up with this formula. He noticed that the radius cubed divided by the time for one orbit squared was the same number for all the planets. That's pretty neat, right?
Whoa.
Whoa. And you know something really neat about Mercury? Mercury's orbit? Remember we said it was a circle, but it's not really a circle?
Yeah, it sometimes moves.
It sometimes moves. And that's called precessing. So here's the sun. And here's Mercury going around. I'm going to exaggerate because Mercury's orbit looks it's very close to a circle, but I'm going to pretend it's a very exaggerated oval. It actually does this. Okay. It keeps, the oval keeps rotating around the sun too.
Cool.
Okay. And you know what the neat thing is? Nobody knew why that happened. Nobody. Until the early 1900s. And then do you know who figured out why that happened?
No.
Albert Einstein.
I wonder why it happened.
Well, he came up with a theory called general relativity. And general relativity predicted that Mercury would spin around the sun, not just going around the sun, but its orbit would actually rotate around the sun. And actually, when they went out and measured how fast Mercury's orbit was turning around the sun, it matched exactly what Einstein said it would be. Isn't that neat? So Mercury's orbit is really, really famous for this. It was really important for Einstein. If that wouldn't have been true, Einstein wouldn't have been famous at all. He would have just been some schlub. But that's one of the things that Einstein predicted that turned out to be true. Isn't that neat?
Yeah.
So lots of people have studied Mercury's orbit over the years. Kepler did, Einstein did, and now, who's the most recent person to learn about Mercury's orbit? Exactly. Good job. Good job. All right, so tomorrow we'll talk about the sun.